Hello students, let us solve a problem from NEET UG Paper 221. Here is the problem. The problem states that a series LC circuit containing 5 Henry inductor, 80 microfarad capacitor and 40 ohm resistor is connected to 230 volt variable frequency AC source. You have to find out angular frequencies of the source at which the power transferred to the circuit will be half the power at resonance angular frequency. So to solve this problem, you should understand the problem from the resonance curve. So this is a typical resonance curve where current is plotted against the angular frequency of the source. You can see there is a frequency omega 0 at which the current in the circuit becomes maximum, and this is called resonance frequency. At the same time, you look, since the current is maximum in the circuit, the power transferred in the circuit also will be maximum, and the maximum powers will be I max square into R at resonance condition, because impedance is equal to R. That's why the maximum power becomes I max square R. Now look, there are two frequencies omega 1 and omega 2 at which the current in the circuit becomes 1 by root 2 times the maximum current which occurs at resonance condition, and hence the power transferred to the circuit at these frequencies becomes half of the maximum power that is transferred to the circuit at resonance condition. So in the problem you have been asked to find out this omega 1 and omega 2. So to find the answers, we need to understand few things. Let us understand this difference between these two frequencies, omega 2 minus omega 1, that is equal to 2 delta omega, which is called bandwidth. So you look, this is delta omega and this is also delta omega. Therefore omega 1 and omega 2 can be defined in this way. Omega 0 minus delta omega is omega 1, omega 0 plus delta omega is omega 2. Hence if you know omega 0, that is the resonance frequency, and delta omega, half of the bandwidth, then the problem is solved. So how do you calculate resonance frequency? We know resonance frequency omega 0 will be equal to 1 by root over LC. If you put the value of L and C, you get omega 0 is equal to 50 radians per second. Now again we know the delta omega can be written as R by 2L, and if you put the value of R and L, then you get the delta omega to be 4 radians per second. Now if you put the values of omega 0 and delta omega, then you get omega 1 as 46 radians per second, and omega 2 you get as 54 radians per second, and hence the third option is the correct answer for this problem. Thank you.